What's up, everybody? I took our notes from today and broke them into 4 videos, page 1, page 2, and 3 and 4. This was the conversation that began around talking about the definition of derivative and how we can use limits. So the example I used, just trying to sketch some sort of smooth curve, something that has some continuity all the way through it, allowing us to not study just simple straight lines or quadratics, but maybe something maybe like a cubic or a fifth root or fifth power, some sort of more complicated polynomial. Setting an initial random arbitrary c location on the x-axis and going up to the y-axis, or going up to the function and then across to the y-axis to note that it is also known as f of c, we're able to begin this conversation around finding the derivative of a curve, and we'll focus on it from the concept of limits. If we use this notation, this function notation, then we have to consider not only the x coordinates, the c values, but also the f of c values. And so that's what I'm representing here in the picture, that we're showing this conversation around slopes. Newton and Gottfried Leibniz were the two, let's say, founders or discoverers of calculus, or the calculus ideas. Newton published first, but Gottfried Leibniz has a little bit more clear picture, and his ideas stick a little bit longer. Most specifically for Calc 1, he was all about slopes, all about how you find the instantaneous rate of change, or how you use this idea of making h, the distance from c out by a certain h value, making it so arbitrarily small, there's that word again, that you essentially cannot discern a difference between c and over c plus h, which kind of means there's almost no difference between g of c and g of c plus h. And then all we really do is we just think about what we did back in Algebra 1, and that's rise over run, baby. You look for the slope of the line. Sometimes we write it out, instead of writing it just specifically with limits, but as a sentence, we could say as h goes to 0, then the distance between c plus h and c, that's the run, that goes to 0. And the distance between g of c plus h and g of c also goes to 0. We're just using the slope formula, like y2 over minus y1 over x2 minus x1. That's our definition of derivative. That's the basis of Calc 1. Thank you for watching this video. Stick around for more. Page 2 coming up. Bye.